Okay, so today we will solve GET 2023 questions. This is a question from complex analysis. It's question number 15. Okay. Let D be, this is the open unit disk in the complex plane, and F is a function, analytic function from D to C, which is defined by this, and two statements are given. F has 3 zeros counting multiplicity in D, and Q is F has no zeros in U, which is in the annulus between half and 1, right? Then 4 options are given, which one is true and which one is false. We have to choose. Okay, so in order to solve this problem, we have, so this is the NPTEL reference for complex analysis. So let's start in solving the question. So in unit disk, so for this we will solve this question by means we have to find the zeros, right? So in order to finding the zeros for an analytic polynomial, we will use the Roche's theorem. So let me write what is Roche's theorem. So this tells us means this, if you know zeros of some functions, known function, and if you compare between two functions, then you can tell the zeros of the other function. Okay, so this theorem tells, suppose two functions fz and gz are analytic inside and on a simple closed contour C. Let's call this contour C. If mod of fz is strictly bigger than mod of gz at each point on the closed contour C, then we can say that then fz and fz plus gz have the same number of zeros, have the same number of counting multiplicity counting multiplicity inside C. So it is saying that if two functions fn and g are analytic inside and on a closed contour of a C, and if it is satisfy this strict inequality on the closed contour, then we can say that f and f plus g have same number of zeros, means its counting multiplicity inside that closed contour. So we will use this theorem to prove our, means to reduce our result for the problem. So first, what it is saying, fz is given z minus 25 z cube z to the power 5 by 5 factorial up to z to the power 11 by 11 factorial on the unit disk, and it is saying that f has 3 zeros inside D. So f is a map from unit disk to C, and fz, this is z minus 25 z cube plus z to the power 5 by 5 factorial minus z to the power 7 by 7 factorial plus z to the power 9 by 9 factorial minus z to the power 11 by 11 factorial, right? So we want to use Roche's theorem. So for that we need to compare between two functions, right? Okay, so we'll choose two functions, so that we choose some function so that we can compare these two, and one will be simpler function, so that we can say that this has this number of zeros. From there we can reduce the number of zeros for f. Okay, so let's take this 8z to be minus 25z cube. This part we will take, right? And now take gz to be the other part. z to the power 5 by 5 factorial minus z to the power 7 by 7 factorial plus z to the power 9 by 9 factorial minus z to the power 11 by 11 factorial, right? So why you have chosen so that such that h plus g, hz plus gz is fz, right? So you have chosen in such a way so that these two add will be fz. So we will compare these two functions. So you have to compare these two functions on the boundary of this curve. So here it is the boundary, we will take this as the boundary of the open unit disk. So it is mod z equals to 1, right? So here C is the contour. Here C the contour is all such z such that mod z equals to 1. So on C, note first, on C means on mod z equals to 1. What is hz? Mod of hz. So mod of hz is basically 25, and this is mod z cube, means it's 1. So 25, right? On mod z equals to 1. And what is the other function gz? On mod z equals to 1. What is mod gz? So if you take the modulus and use the triangle inequality, what you will get? So you will get mod z plus mod z to the power 5 by 5 factorial plus mod z to the power 7 by 7 factorial to the power 9 by 9 factorial plus z to the power 11 by 11 factorial. So this is less than equals to, right? And mod z equals to 1, so I put just 1. So this is basically putting 1 plus 1 by 5 factorial plus 1 by 7 factorial plus 1 by 9 factorial plus 1 by 11 factorial. Now I can make it all of these are less than equals to 1, so I just make it less than 5, right? So what we have get? Gz is less than equals to 5 on mod z equals to 1. So from here, from these two, we get mod gz is strictly less than mod hz, right? On mod z equals to 1, right? So now look at this Roche's theorem. It is saying that if two functions satisfy this strict inequality on a certain contour, then inside that contour f, this function, and f plus g has same number of zeros, right? So therefore using Roche's theorem, therefore by Roche's theorem, hz and gz plus hz. What is gz plus hz? fz, right? So by Roche's theorem, hz and fz have same number of zeros. So this is counting multiplicity, right? inside mod z equals to 1, right? And what is hz? Note hz is what we have chosen, hz to be minus 25zq, right? So how many zeros it has inside this unit, its unit circle? So therefore, so it is 3 zeros, right? Because it is a polynomial of degree 3 and all these are 0. So 0 are the root with, so it is 0 is a 1 root with multiplicity 3. So therefore hz has 3 zeros inside mod z equals to 1, right? So therefore fz has also 3 zeros inside mod z equals to 1, right? So this is the first option. We have to, it's saying that we have to find that if fz has 3 zeros inside mod z equals to 1, means in the open unit disk. So the first option is correct, right? P is correct. So now let's check the next one. What it is Q saying? F has 1 0 in this annulus up to 1, right? So you have found out that it has 3 zeros inside this disk, means open unit disk mod z less than 1, but it is saying that F has 1 0 inside this annulus. Okay. So now what is U? So this is done, the first one. Now what is U? U is basically Z belongs to C such that this is the annulus between half to 1, right? So suppose this is this. So this is the annulus of radius half, and suppose this is the annulus of radius 1. So this is this annulus, right? Half and 1. So we have get that F has 3 zeros inside this unit disk, but we have to find how many zeros inside this annulus. So if we will again use the Roche's theorem for this mod z equals to half, and we will see how many zeros inside this and inside this card mod z equals to half. So here we will take the contour mod C equals to what we will take, all such z such that mod z equals to half. Again, as earlier, we will take this two functions, hz equals to minus 25z cube and gz to be z plus z to the power 5 as early, right? Z to the power 7 by 7 factorial plus z to the power 9 by 9 factorial minus z to the power 11 by 11 factorial. So on mod z equals to half, what is this mod of hz? So it will be 25 into 1 by 8, right? So 25 by 8. And on mod z equals to half, what will be mod of gz? So mod of gz, it will be less than, right? So if we write down, you can, what you will get basically 1 plus 1 by 5 factorial into 1 by 2 to the power 4, means I have taken half common from everything. So this you can write 1 by 7 factorial into 1 by 2 to the power 6 plus 1 by 9 factorial into 1 by 2 to the power 8 plus 1 by 11 factorial into 1 by 2 to the power 10, and all these are less than 1, so half times 5. So what we have got, this is 5 by 2. So on mod z equals to half, gz is less than 5 by 2. Okay, so therefore mod gz, this is strictly less than mod hz on mod z equals to half, right? Therefore again by Roche's theorem, gz, hz and fz has same number of zeros, right? So by Roche's theorem, hz and fz, so this is basically right, hz plus gz has same number of zeros. This is counting multiplicity. Inside mod z equals to half. And how many zeros hz has inside mod z equals to half? As we know, hz is minus 25z cube. It has all the roots are 0. So hz has 3 zeros. Inside mod z equals to half, right? So therefore fz has also 3 zeros inside mod z equals to half. So what we have got? So therefore note, first what we have got, that inside, so as fz has 3 zeros, so this is again counting multiplicity, right? Let me write counting multiplicities. So counting multiplicities. Inside mod z equals to 1 and 3 zeros, so again counting multiplicities. Inside mod z equals to half, right? So what it is saying, in open matrix it has 3 zeros, and inside this mod z equals to half it is again 3 zeros. So therefore there is no zeros in the annulus, right? Therefore fz has no zeros on u, so this is the annulus, half less than mod z less than 1, right? So this is the second option. What it is saying? Saying that f has 1 0 in the annulus, so this is false. So this is not correct. Q is not true. So therefore P is true, Q is false. So the first option is correct. Okay.